So now, of course, if you want a logic gate, you're probably going to want to use an integrated circuit. This is the 74HC08, the High Speed CMOS version of the 7408, which is a quad AND gate. There's 4 AND gates in there. So you can see no matter how high I set the voltage with the trim pot there, the output stays low. The LED stays in place. I'm going to move this jumper here. This is the other input right there. And you can see we had some jumping around. That's called a switch bounce. But in any case, now we got 5 volts at the second input. So we had both inputs low, output low, one input or the other input high, but the other input low, it stayed low. Now we'll set both inputs high, and there you can see that now the output went high. We got the red LED lit up there. Now we will go and take a look at if we set the trim pot about halfway and see what happens. We saw some weird activity. There you go. So it doesn't like this middle ground region. So that's one good reason why it's a good idea to do tests like this. You get a better feel for what the integrated circuit is doing. Ultimately though, always check the data sheet. All the information we gather from here, you can gather from the data sheet if you know how to read it. And now we'll look at the diagram, which I actually made a long time ago. We have the 7408, so that means there's 4 AND gates on this integrated circuit. The high-speed CMOS version, which determines the power capabilities for the most part. There's other factors, including what the output did when we got the voltage about halfway. We saw things went a little erratic. But in any case, you have to power the integrated circuit. Positive supply to 14, negative supply to or ground to pin 7. All the inputs that you are not using need to be tied to a supply voltage. So I put these two to ground because they're next to the positive supply there. But these other ones I used yellow jumpers because I got a bunch of them I'm not using for anything else. Going to the positive supply. This one's actually powering the LED when the output is low. Now we have the schematic symbol there for a AND gate, and I'll just do a quick demonstration while we don't have the wiring for the probes there. I think you can see how that's all wired, so I'm not going to go over that in much detail. I've done similar wiring in other videos. And so you can see when the output's high, they don't always show the power supplies on the schematic symbol. Red LED lights up. When the output's low, ground there, the blue LED lights up. Pretty straightforward. So being a high-speed CMOS integrated circuit, this is pretty typical there. The outputs can sink or source 25 milliamps of current, so plenty for LEDs, which you normally limit to 20 milliamps of current. But there's a total supply current for the whole integrated circuit of about 50 milliamps. So if you were using all 4 of them to light LEDs, you'd have to lower the current to, you know, somewhere around 10 milliamps of current, so that if they're all on, you're not exceeding 50 milliamps of current. But again, this being an AND gate, it has the basic property of if any of the inputs are low or 0 volts off, whatever the case may be, then the output is low, 0 volts. And if all the inputs are high though, that's the only state where the output goes high or 5 volts, whatever the case may be. So this is my short video series. This one's gone on longer than I wanted, so we're going to end it there.